Not there today, but we are going to be talking about operations, functions of operations, and composition of functions. So let's go ahead and get started. A lot of this is going to be review from Algebra 2. So let's go ahead and get into it. All right, so if you have two functions, an f of x and a g of x, there are several operations that you could do with those functions. First and foremost, you can add the two functions to each other, subtract, multiply, and divide them. So when we add the two functions to each other, we can say, all right, take f of x and then add to it g of x. So that'll be f of x plus g of x. But in order to make the notation a little bit more concise, we can also write it as f plus g of x. Okay, so then if I write, let's say, f minus g of x, what I'm doing is I'm taking my f, subtracting g, and this is all a function of x. So it's just f minus g. That's all that is. Okay, so here we have two functions, and we're going to perform these four operations on these two functions. So let's go ahead and do that. All right, and then we're going to go back and do domain. So first, I want to find f plus g of x. So for that, I take f of x, x squared minus 2x, plus g of x, 3x minus 4. Combine like terms. So f plus g of x is equal to x squared plus x minus 4. Next, I want to do f minus g of x. So that's going to be f minus g of x, right? And because I'm subtracting, I have to be careful and put that in parentheses. Now I'm going to distribute. So I have x squared minus 2x minus 3x plus 4. So f minus g of x is x squared minus 5x plus 4. All right. I'm going to leave some space and then come back for domain. Number 3, now I want to do f times g of x. So for here, I want to take f of x and multiply by 3x minus 4. So when I distribute, I'm going to have 3x cubed minus 4x squared minus 6x squared plus 8x. So f times g of x is 3x cubed minus 10x squared plus 8x. Finally, if I want to do f over g of x, okay, I'm going to divide them. So f is x squared minus 2x divided by 3x minus 4. Now in this case, a lot of you are going to be asking me, hey, do I have to factor out an x from the top and so on? Well, here's the answer to that. If, when you factor something out, you are able to cancel and get rid of something with the denominator and so on, then yes, you must factor out, reduce, simplify, and do all that stuff. However, if by factoring out, it's not going to take you any further in terms of simplifying or canceling, you could just leave it the way it is. So here, I'm just going to leave that the way it is. All right, let's go back and do domain. The domain of this function, look at what we get. We get a nice, cute little polynomial function. And we know that the domain of polynomial functions is all real numbers. So it's just negative to positive infinity. Same with this. Domain, negative infinity to positive infinity. For number 3, I get another polynomial function. Oh, and I just realized this should be a 3. I get another polynomial function. The domain is negative infinity to positive infinity. Here, right, my complication is that the denominator can never equal to 0. So 3x minus 4 can never equal 0, meaning x can never equal 4 over 3. So my domain is negative infinity to 4/3 and then 4 over 3 to positive infinity. Okay, so much for that. All right, so let's move on to compositions of functions. In this case, this is when you have two functions and one gets nested into another. So for example, if you have f of g of x, right? And then another notation is f of g of x written this way, right? So g gets inserted into f. All right, so let's take a look at this one. For each case, we have to find f of g of x, g of f of x, and f of g of 2. All right, so let's take a look at our first example. If I want to find f of g of x, I have to put g into f of x. That means wherever I see an x in f of x, I need to put in the entire g of x function. So this is going to be 2 times x. Now x is going to be g of x. So 2 times x squared minus 1. All right? That's f of g of x. When I simplify, I get 2 times x squared plus 6x plus 9 minus 1. This is equal to 2x squared plus 12x plus 18 minus 1 is plus 17. So that's f of g of x. In the second case, I want to do g of f of x. That means f is going to get inserted into g. So what is g? It's x plus 3. So I put in my other function instead of x plus 3. And so finally, g of f of x is 2x squared plus 2. Lastly, I need to find f of g of 2. Now, we already found f of g of x here. So one thing you can do is you can plug 2 into this expression. However, if you weren't first asked to find that, all right, just out of the blue, you have to find f of g of 2, there is another way that is more efficient that I like to do. So this is f of g of 2. What I do is I start from the inside and I find g of 2. G of 2 is 2 plus 3, 5. Now I go back to the outside and I find f of that number 5, and that will be 2 times 5 squared minus 1, 49. All right, so let's do the same thing here. First, I want to find f of g of x. So what's f of x? F of x is the square root of x minus 1. Now instead of x, I'm going to put in my other function, x minus 1 squared minus 1. So here I have x squared minus 2x plus 1 minus 1. So f of g of x, these notations are interchangeable, is the square root of x squared minus 2x. Okay, so now let's do g of f of x, right? So what's g of x? It's parentheses x, right? But instead of x, I'm going to put in f of x. Okay, so x minus 1 squared. Okay, let's square this. I square the first term, x minus 1, minus 2 times the square root plus 1. So now the negative 1 and the positive 1 go away. So I have x minus 2 root x minus 1. This is g of f of x. Now, number 3, I want f of g of 2. I'm going to start with g of 2, and that's 2 minus 1 squared, 1. And so finally, f of 1 is the square root of 1 minus 1, 0. All right, awesome. Moving right ahead. Now, it's one thing to be able to put f of g of x together, but you also have to be able to take it apart, to decompose it, all right? And this is very important in calculus, is to be able to decompose functions into the simpler functions from which it came, right? So here I did f of g of x, and I got x squared minus 2x in the square root right here. Well, can I now, take part and come up with f of x and g of x? And I know that, there are cases where it's not that clear, but then there are also cases which is in which case it's very, very obvious. All right. So to decompose a function h, we have to find two functions, f and g, such that f of g of x is equal to h. So for example, take a look at this one. H of x is 3x minus 1 quantity squared. Now, if you look at this, you always have to look for an outer function and an inner function. If we are looking at this function from far away, what is the outer function? The outer function, you see that from the very, very outset, from very, very far away, you have some quantity squared, right? So that is my outer function. I say f of x is x squared. That's my outer function. Now, when I zoom in, I see that within the stuff that's being squared, like there is something else inside, and that's 3x minus 1. And this is my inner function. Okay? Now, all right. So let's take a look at these. Find two functions such that, h is f of g of x. Okay, so here I have 1 over something squared. So think about it as if you're looking at it from far, far, far away. You don't see any details. All you see is the silhouette of 1 over something squared, right? So I take that as f of x, 1 over some quantity squared. And then when you get closer and closer, you realize, oh, there's something else inside. The stuff inside, let's call it g of x, is x plus 2. So let's check. Let's see if this works. Let's check this out. What's f of g of x for these two functions? Well, it's 1 over x plus 2 squared. Yep, that's exactly where those two came from. So take a look at this one. From the very, very outside, right, it looks like I have an absolute value minus 3. And then when I get closer, I realize, oh, inside there is something else, a 5x plus 2, right? So together that makes h of x. Now, this last one is tricky, and I won't really ask you for one like this on the test. I just put this one here, because it's a fun little exercise to do. So in this case, we have to figure out our f of x, and then we have to figure out our g of x. Now you can't cheat, so you can't say, f of x is x over the square root of x squared minus 1, and then g of x is just x. No, it won't work like that. And there is more than one way to decompose this, but there is a clever little way, which is, again, it's not very obvious, but I'll show you how it is. So one thing you could do is you could say f of x is root x over root x minus 1. G of x is x squared, right? And now when you plug it in, the square root of x squared is x over root x squared minus 1, and so on, right? So this, I just put it in here for fun. All right, but you should know things like a and b. All right, let's move on to bigger and better stuff here. You have a function here, 1 minus 1 over x. Now you are asked to describe the behavior of the function as x approaches 0. Describe the behavior, that's a limit, okay? So what you're being asked for here, the limit of this function as x approaches 0. So we want the limit of f of x as x approaches 0. Okay, that's what the question is asking for. That's how we translate that sentence into math. And so now when we plug in our given, we have the limit as x approaches 0 of f of x, which is 1 minus 1 over x. Okay, now this problem does not really have a lot of calculations. This is more of a mental exercise, and it's very, very important for us to be able to reason through this in Precalc Honors. All right, so here what we're doing is we are saying x is approaching 0. All right, so x is becoming exceedingly small. All right, take a look at what we have here. I have 1 over x. If the denominator becomes smaller and smaller and smaller, let's think about what happens to the fraction, right? So if I have 1 over 1,000, that's 0.001. And if I have 1 over 100, make the denominator smaller, 0.01. 1 over 10, 0.1. 1 over 1, 1. Right? So the denominator is getting smaller and smaller from 1,000 to 100 to 10 to 1. What's happening to my value? It's getting bigger and bigger and bigger. And so now if I make the denominator even smaller, 1 over 0.1, my value becomes 10. 1 over 0.01, my value becomes 100. So as the denominator gets smaller, the value of the entire fraction is getting bigger. Okay? So as x becomes small, 1 over x becomes larger and larger, and it approaches infinity, right? So, you have like 1 over x approaches like 1,000,000, 1,000,000,000,000, 100 trillion, and so on. So now I have 1 minus a very, very large number. So what happens if I have 1 minus 1,000,000? It's negative 999,999, right? So 1 minus an infinitely large number is an infinitely large number, but negative. So this will be negative infinity. Okay, so the important thing here is that when the denominator becomes very small, the entire fraction becomes infinitely large. 1 minus a very large number is a very large negative number. Okay. Now, one thing you have to be wary of, we don't ever write something like 1 minus infinity, never. Okay? It's something, you can say it approaches infinity like this, but never write it as 1 minus infinity. That will be points off. All right, so now describe the behavior of the function as x approaches infinity. So now I want the limit of f of x as x approaches infinity. This is the limit as x approaches infinity of 1 minus 1 over x. Now we have the opposite situation. I have here 1 over x. Now x is becoming infinitely large. So if I have, 1 over 10, that's 0.1. But then if x becomes infinitely large, 1 over 1,000,000, oops. Okay. Then my value is very, very small. Okay. So as the denominator becomes exceedingly large, 1 over that large number approaches 0. And so I have 1 minus 0 that I can write is equal to 1. All right. Last but not least, take a look at what we have here. We have f of x and g of x. You had something similar to this in the homework. I have f of x and g of x, and we have to find, what we're being asked for here. So in the first case, I have f plus g of 0. What this is f of 0 plus g of 0. Okay. F, if you look, I know yours is all one color, but F in my version, it's the blue, right? So F of 0, it's this point here. I'm going to estimate it to be about -6. I know it looks like it's a little bit off, but I'm going to estimate it to be about -6 plus g of 0, that's in the red. It looks like it's also -6. So together, this is -12. Okay. Next, what I have here is f of g of -4. So again, I start from the inside. G of -4, right? G at -4 is -4, right? So when x is -4, g is also -4. And then when I go outside, f of -4, f of that number, -4, is also -4. All right, so f when x is -4 is also -4. So that's the answer to that one. All right, guys. So when we see each other again on Thursday, we will start by answering questions from the homework for Section 5 and Section 6. Please make sure to have this done by Thursday. And then after we do questions from 5 and 6, we're going to move on to Section 7. Thanks, everyone. Bye-bye.